page 51. Right? We're going to look at polynomial and rational inequalities. All right, these are things that right now you may wonder, and I'm sure you will, like, why in the world do I even care if I know how to do this? Well, it is going to be applicable. We can't apply it till we know how to do it, right? But it's something that they're actually doing today, literally today, in AB next door. And so it's something that we need to be able to do to apply to what we're going to do coming up. But then there are times where, because we're going to look at when are these functions positive or negative, right? And because we found our zeros, we can do that all day long. But maybe I don't care what the y value is when x is 3, but I do care about when is the function positive, when is it negative, when is it increasing, when is it decreasing. That tells you all kinds of things when you go to apply that to the calculus and to some other real world stuff. So we're going to look at today how to figure that out from what's called inequalities. I do want to make a quick side note because somebody asked a question. It took him a long time to get the question out last period, and then I finally realized what he was trying to say. So I don't want you to get this confused with this, and I'm almost afraid to say anything because then it might confuse it even worse. But do you remember doing where you had inequalities and you were shading them? Like you draw a line and then you would shade up here or whatever, like that? That is not what we are doing. It is completely different than that. That was when you would say like, y is less than 3x plus 4 or something like that. We don't care about y. That's like all the y values that are less than that function. We just care about when is the function itself less than 0. 0 is the only one we care about, okay? So it's a different concept than this. So I don't want you to try and be tying it to it or be confused about it. Totally different thing, okay? Oops, I just erased everything. Okay, sorry, I'll put that back. Okay, so polynomial inequality. It says, given a polynomial function, f of x, a polynomial inequality has the general form of, it could be any of these. Basically anything you could write where you don't write that it equals 0. That's what makes it an inequality, not equal, right? So an inequality f of x is greater than 0 is true when f of x is, what do you think? It's not a trick question. Positive, exactly. It's positive. So it's greater than 0 when the function is positive. And then the inequality f of x is less than 0 is true when f of x is negative, right? It's that easy. So it says, look at this function and its graph below, and we're going to name the intervals for when f of x is greater than 0. So that means, when is it positive? Well, it's positive here, and it's positive here, and it's positive here. So the intervals on which it's positive are negative infinity to negative 3. Do we include the negative 3? No, because then would it be greater than 0 if we included the negative 3? No, at negative 3 it's what? Equal to 0. It is 0. Yeah. So that's why we're not including it. And then it's also positive from negative 1 to 0 and from 1 to infinity. Okay, everybody okay with that? So then we want to name the intervals for when it's less than 0. So that's when it's negative, here and here. So it's negative from negative 3 to negative 1 and from 0 to 1. And if you snap those two together, you'd have everything included except for the zeros themselves. Does that make sense? You got all those pieces taken care of. So that's fine and all fine and great and easy to see when you have a graph. But if we don't have a graph, we still want to know that, but without graphing it. So that's what we're going to do here to solve these inequalities without actually graphing them. So here are the steps. Now the first step, I didn't like the wording, so I changed it, and then it was pointed out to me that this really makes absolutely no sense, and they're 100% right. But I still don't know how to word it correctly. It says, because what I put is, set the inequality equal to 0. Well, you can't set it equal to 0 if it's an inequality. You see how that makes no sense? Okay, so what I was trying to get at is that you have to have it less than 0 or greater than 0 or whatever. So basically, set the inequality, I guess we'll just say to 0. You have 0 on one side and everything else on the other side. That's what I'm getting at. As long as you understand it, it's fine. I can't find the exact right words to get my point across, but that's what we're going. So then we completely factor it, find the zeros. We can do that for sure. Then we plot them on a number line, and we choose some test points, and from there we make a sign chart. So I'll kind of walk you through the rest of those instructions. So let's look at number 1. All right, it says solve each inequality. Well, we're supposed to set it to 0, which, boom, it's already done. That was great. Then we factor it. Right? And so this is x, this is x. So it'd be plus 6 and minus 1. Right? So we factored it. We know that those two factors multiplied together are supposed to be greater than 0. So then we write out our zeros. They're going to be 1, or no, I'm sorry, I should have done negative 6 first. Negative 6 and 1. Okay, so those are my zeros. Then those get put on the number line. Now, the number line does not have to be accurate and to scale. Okay, sometimes it's better that it's not. So as long as you just put 2 hash marks on there, this is negative 6 and this is 1. They do have to be labeled or you're going to be way confused, like you need them to be labeled. But you don't have to worry about if they're spaced correctly or anything like that. So then I have to decide, these are my zeros on my number line. Would they be open circles or closed circles? Open, because it just says greater than, right? So open circle, open circle. And you can think of this number line as your x-axis, because those are like literally the zeros that are on there. So all I care about is where is this function positive and where is it negative. So like what, I don't even know what it looks like, but are my y values up here or are they down here? So we choose some test points. So we'll go from negative infinity to negative 6. In this whole interval right here, you can choose anything that's easy to work with. So we can choose like negative 7. So when I substitute negative 7 in here, is this term going to be positive or negative? Negative, so I'm going to put a negative sign. When I put negative 7 in here, is it going to be positive or negative? Negative. And I don't care about the number itself. Like I'm not actually substituting it in. I'm just substituting kind of sloppily in just to know if it would be positive or negative. You with me? So if I take these 2 negative numbers and multiply them together, what kind of number am I going to get? Positive. So that means overall, the function is positive right there. So all the y values from negative infinity to negative 6 have to be above the x-axis. Make sense so far? So then I'm going from negative 6 to 1. So in between there, zeros in there, right? So if I substitute in 0, this is positive. I substitute 0 in here, it's negative. What's negative times positive? Negative. So between negative 6 and 1, it's negative. The only place where you can change from positive to negative is when you cross through the x-axis, right? That's why we care about our zeros. So if I can't change from positive to negative down here at negative 10 because I don't get to cross the x-axis. You with me? That's how I know for sure no matter what's going on, all of the y's are above the x-axis. And then if I choose another one like 2, so I substitute in 2, this would be positive and positive. And overall, this is positive. And yes, it alternates back and forth, but no, that does not happen every time. If it happened every time, then we wouldn't need to check them like this. You with me? So just keep that in mind. It's not always that, and it's not always that. So then we shade. Since it's positive, and I'm thinking about this line as my x-axis, all my y values are here. Negative, all my y values would have to be here. Positive, all my y values are here. Okay, so that's just some things that I know about the function. Then I can use this because what I want is for when this function is greater than 0. So what am I looking for, positive or negative? Positive. So I know that it's positive from negative infinity to negative 6. Do I include negative 6? No. And then it's positive from 1 to infinity. And this is my answer. That's when my function is positive. Okay? Questions? Stick with me on the process right now. As we go through this, if it's not clicking with you like what this means and why we're doing it just yet, that'll come here in just a minute, okay? All right, so flip this over. Let's look at number 5. All right, so on number 5, I need to set it to 0, which means I need to move this 4x. I mean, I could move all this over there, but I don't know why we would want to do that. So move it over here. So 3x cubed minus 11x squared minus 4x is less than 0. Then I need to factor it. So what's going to be the first thing I do? Get GCF. X, so I get 3x squared minus 11x minus 4. And then go ahead and factor that second part. And you can factor it by, your grouping, divide, and slide, looking at it and knowing like whatever works for you. Oh, not minus 12. Dang it, sorry. I wrote the wrong number. My brain and my hand don't always agree. All right, so this is what we get when we factor it. Y'all agree with that? Okay, so we get x equals, my smallest one's going to be negative 1/3, then 0, then 4. Good. Now, negative 1/3 and 0 are really, really close to each other. We agree with that? I don't care that, I don't even want to try and do that on my number line because I need room in there for me to actually put my negative and positive signs. So I just know that I have 3 zeros. I'm pretty much just going to evenly space them because it doesn't have to be a real accurate number line. So I get negative 1/3. Actually, it was a real accurate number line, and I took all that off because there's that close, it's impossible to deal with. And then 0 and 4. Nobody's judging the spacing on your number line. All right, so then are these opened or closed? Open. Good, because this is not an or equals to. So open, open, open. All right, so then from negative infinity to negative 1/3, I could choose like negative 1, right? So negative 1, how many terms do I have to substitute this into? 3. Don't forget about this guy. There's 3 things here. So negative 1, that would make that negative. Negative 1 in here is going to make that negative, negative. So overall, that is negative. What's a number between negative 1/3 and 0 we could use? Is negative 1/2? Negative 1/4 works. Okay, so some of y'all are trying to do some reasoning, right? Like, it should be negative 1/2 or negative 1/4. Which way to go? Well, somebody learned it out in 3rd period, negative 1/6. So if you just take half of that, isn't it going to be small? I mean, going to be bigger, smaller, whatever. So, if I just multiply by 1/2, negative 1/6, that one works right there. Or negative 1/4. Like, it doesn't matter. Either one, you'll get the exact same answer, but you can think through it kind of either way. So let's use negative 1/4 because I heard somebody in here say that. So if I use negative 1/4, this first one obviously is going to be negative. And then this would give me negative 3/4 plus 1, which means that would be positive. And then that would be negative. So overall, it's positive. So between 0 and 4, I would choose 1. Be easiest, right? So we're going to get positive, positive, negative. So it's negative. Then I would choose 5. So that would make it positive, positive, positive. And that's positive. And I know it alternates, but I'm going to say once again, that does not happen every single time. So don't start assuming that and then just making stuff up. Okay? All right, so then I shade. Negative, positive, negative, positive. Do I want these to be negative or positive? Negative. Less than 0, right? That's how we decide, is based on that sign. The function less than 0, so that means I want the negatives. So I go from negative infinity to negative 1/3. Do I include the 1/3? No. And then from 0 to 4. What questions do you have? Yes. So like equal to 0 doesn't make any sense because there's no equal sign. Whatever the sign is there, I leave it there, and I only switch it if I multiply or divide by a negative. Otherwise, it is what it is, whatever they gave me. Okay? Does that make sense? Okay, good. Anything else? What else? Yes, because it says less than 0. If it said greater than 0, I'd only write the positives out. It depends on what the question itself states. Okay? Good question. What else you got? That it? All right. Let's look at number 6. So I would move everything to the left, right? So I get x to the 4th plus 4x cubed minus 9x squared minus 36x is greater than or equal to 0. Yes, so I can factor out the GCF. So I'll get x times x cubed plus 4x squared minus 9x minus 36. That's greater than or equal to 0. You could factor by grouping. So go ahead and go ahead and factor it the rest of the way. bless you. Okay, so do you end up with 4 zeros? Yes. Got -4 plus or minus 3 and 0. Are you making up math over here? No making up math. No room for... That's a 9. Where'd you get x cubed right here, babe? Oh, you didn't factor out the GCF first. That's why you're getting funky stuff. That should be, no, the plus or minus you could argue either way, but you should be going from least to greatest as much as you can. Now, whether plus or minus 3 is on either side of 0, we could argue it either way. Or you could separate them out, but that's fine. All right, so I'm going to have 4 things here. I get -4, -3, 0, and 3, right? Are these opened or closed circles? Closed. So all 4 of them are closed. Then when I go to find the signs for this stuff, because I write kind of big and I'm going to have 4, they're not going to fit going horizontally, so I'm going to write them vertically, because you can do them either way, it doesn't matter. From -infinity to -4, I'd pick -5. So when I substitute it in here, that's obviously negative. -5 here would give me negative, negative, negative. So 4 negatives multiplied together give me what? Positive. Okay, between -4 and -3, I'd use -3.5. So the first one's definitely negative, then negative, negative, then positive. So that makes that negative overall. In between here, I think I'd pick a -1. So it'd be negative, positive, negative, positive. So that would be positive overall. Between 0 and 3, I think I'd pick 1. So it'd be positive, positive, negative, positive, negative. And then maybe 4, so it'd be positive, 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 positive. Overall, it's positive. Then I shade. Shade, shade. Trust me, the shading may not look like you need it right now. You might be thinking, well, I could figure that out without it. But once we get to graphing, you're going to be glad that you're used to shading. Just trust me. And I know some of you will never trust me because you think I make stuff up just to make your life harder. And I promise you that's not the case. I wouldn't make you do it if it wasn't important. All right, so I've got all that. Now, do I want this to be, am I looking for the positives or the negatives? Positives, because it is greater than or equal to 0. So that means I'm going from -infinity to -4. I never include infinity. Do I include 4? Yes, this time I do. Okay, and then the next positive goes from -3 to 0, and I'm including those. And then from 3 to infinity. Okay. What questions do you have? We good? Okay, you're good. You got it now? Yeah, okay. I kind of have a feeling you were asking a question, but then you figured it out as you were asking it. Okay. Okay, shh. Go ahead. Yes, that's a very good question. So, Damien's asking about in behavior. On that note, I'm going to show you what else this tells you. So, above number 6, draw a little arrow, and then draw another line, because I just don't like that line. And we're going to make a number line, but this time we're going to actually space it correctly, or a little bit more accurately anyway. So I'm using the exact same problem though. So I'm going to have -4, and then -3. And then I have to think about that as being like 2, 1, 0 would be about right here. And then 1, 2, 3 would be about right here. Okay. So this number line is basically representing your x-axis. So all we have is an x-axis represented. Let's draw in our y-axis. So this is our y, this is our x, right? Our points were all closed here. And so because we know this, down here from our sign chart, that it's positive between -infinity and 4, and then it's going to, and we know where it's positive, negative, and it does alternate. So it's positive, then it switches to negative, then it switches to positive, then it switches to negative, then it switches to positive. And that is very much like the sketching of the polynomials that we were doing. You wouldn't have to like draw a separate one like this. We could have drawn it through on your number line, but I think it would have been a little confusing. So I think what you were asking me was, since you know it's even, and you have so since it's even, the end behavior should be the same on either way, on either side. So since this is positive, you pretty much know the last one has to be positive, right? And that's true, and that's exactly what's happening up here. What this wouldn't tell us is the y-intercept, unless the x-intercept also happened to be 0, 0. So we kind of lucked out on that one. But it at least gives you some of that same shape and kind of gives you some idea. That's where it's going to come in hugely handy when we start looking at the rational stuff. Okay. All right, so let's look at number 7. Go ahead and start factoring number 7. Okay, so what's happening? Okay. Well, not that you can't factor it by grouping, right? So if we can't factor it by grouping, what do? The cubic formula that doesn't exist. Or we can try and force it into the quadratic formula, which some people did. Okay, y'all turned in an assignment, I think on Monday, where the last 2 questions, most everybody left blank. And that tells me a lot. That tells me that you don't go back and look at your notes. Because you're just like, I don't know how to factor this, so I might as well just give up. Instead of thinking, I don't know how to factor this. What did we do when we couldn't factor something? What did you say? Find out the possibles, yes. So we had to do some synthetic division, right? But we didn't just randomly guess out of an infinite amount of numbers. We narrowed it down by finding our possibilities, right? Based on this coefficient and this coefficient. Okay? Which, this is 1. This is great when this is 1. So it's really just the factors of 16. Plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, plus or minus 16, right? Those are the ones I get to test. And you get to choose whichever one you want to start with. Well, 1 is the easiest, so why not start with 1, right? We start with 1. And we get 1, negative 9, negative 24, negative 16. Positive 24, thank you. Making stuff up. See, like I told you, there's no room for, you don't get to make stuff up. Me either. Nobody does, it's not fair. So we bring down the 1, and we get a 1, negative 8, negative 8, positive 16, 0. And it works, and it's very exciting when 1 works, right? Or at least the first one you choose, even if it wasn't like, thank the Lord, it worked. So this is x minus 1 times x squared minus 8x plus 16, and that is greater than 0. Don't lose your inequality sign in there because you want to make sure you're using the correct one. All right, so then go ahead and see if you can factor the second part. Okay, then do it. Okay, maybe let me clarify. See if you can, and then actually do it. Okay, so this is a special case, but most of you would probably write that out anyway. Not all of you, because I'm hoping all of you wouldn't have to write that out every time. It's a perfect square trinomial, which hopefully you can get to where you actually recognize that. If not, and you factored it like this, it's fine, but you can't leave it like this. This is not finalized. This would have to be x minus 1 times what? X minus 4 squared is greater than 0. Okay? So this is what we're using for our number line, right? So what are my x's? 1 and 4, yes. So on my number line, I just have 2 numbers, 1 and 4. And are they opened or closed? Open. Right? So then I check my signs. From negative infinity to 1, 0 falls in there, so we like 0. If I substitute 0 in there, that's negative. If I substitute 0 in here, what do I get? Positive, because you square it. So no matter what real number you substitute into this part right here, want to be positive every single time, so you don't have to check it anymore, right? I mean, you got to include it, but you don't have to like check it, like use brain cells and stuff. So if I do 2 in here, 2 minus 1 is positive, and then the second one's still positive. If I use 5, it's positive, and then the second one's positive. So this is negative overall, positive overall, positive overall. So then I shade. See, it didn't alternate. I told you it doesn't alternate every single time. And it doesn't alternate because I heard somebody here say it, and I just didn't say anything then, but I heard multiplicity, right? And that multiplicity of 2 means you have what? A bounce, which means, what's the real word for that? Tangent. As long as we know the real word, we can use the other words, but bounce. So if I was to sketch this, and remember, I can sketch this right like in my number line. This is negative, so I start down here. It's positive. It bounces off the axis and comes back up, and it looks like that. And that's what it would be. It's odd, so the end behavior is opposite. I know if it's starting positive or negative, and that's what's happening there. That's why it doesn't switch. So just because you can switch it to 0 doesn't mean you always do switch it to 0. Okay, we good on that? What questions you got? Awesome. Grab your second sheet of paper. Oh, did I not answer the question? I didn't answer the question, did I? Thank you. I didn't answer the question. I was so excited about my graph. Thank you. We are looking for the positive, so yes. Then it's going to be, and this is an important one to talk about too, I'm going from 1 to 4. Do I include them? No, because it's open. And then I go from 4 to infinity. Now, had these been closed circles, then I wouldn't need 2 intervals. If these were closed circles, I could go from 1 to infinity, because then I'd be allowed to include the 4. Does that make sense to you? There'd be no reason to split them up. Thank you for pointing that out. Okay. This is going on page 52 when we are done. Okay, so the first part of this sounds almost exactly like what we just said with the polynomials, but things are just a tiny bit different. All right, so given a rational function, a rational inequality has the general form of this. Basically writing it where you do anything but equals. So the inequality f of x is greater than 0 is true when f of x is what? Positive. And the inequality f of x is less than 0 is true when f of x is negative. Okay. We good with that? Yes? Okay. So now we're going to look at the function, and it's already graphed for us. We're going to get into the graphing of rationals here pretty soon. But what do rational functions have that polynomials do not? Asymptotes. There's a few things, but asymptotes is what I was going for. So we're going to draw these in because those are important, right? So I have these asymptotes here. And then it says to name the intervals for which f of x is greater than 0. Well, it's greater than 0 here, here, and here. So those intervals are negative infinity to negative 3. And I don't include them because you cannot, if it's an asymptote, there's no reason you're not going to include it. And plus it says greater than, so we're not using that either. And then it's positive from negative 1, oh goodness, to 2. And then from 4, yeah, from 4 to infinity. So then I want it when f of x is less than 0, so it's less than 0 here. Those are my y values, and here. So that's from negative 3 to negative 1, and from 2 to 4. Okay. And again, if you snap them together, you have everything except your zeros and your asymptotes there. You're using both of them. So our steps are pretty much the same. Okay, it changes just a little bit because we have asymptotes, because we have to find the zeros of the numerator and the denominator. The zeros of the numerator give us the zeros of the function. The zeros of the denominator give us our asymptotes. And once again, this set the inequality to 0 makes a little bit more sense. But then when we find the numerators and the denominators, so we are finding the zeros of the numerator and also the asymptotes, we plot all the points on the number line. Asymptotes always get an open circle. Always. Okay, because the opened and closed for the others are based on whether or not we're including the 0, but we never get to include those vertical asymptotes like that. Okay? All right. So let's see. We're going to flip over on the back and we're going to start with number 5. Okay. Okay. So the first thing I need to do is factor, and I have to factor the numerator and I have to factor the denominator. So the numerator is going to factor into x minus 1 and x minus 4. And the denominator is x times x plus 2. So then there's two things that I'm finding here. I have to find my zeros. Those come from the numerator. They are 1 and 4. I have to find my asymptotes. Those come from the denominator because you don't get to divide by 0. So if they're made zeros, that's where your asymptotes are. So the first one is x equals 0. And the second one is x equals negative 2. And it's written that way because those are equations of vertical lines. That's why you have to write them like that. Now there are 4 things that go on my number line. I have a negative 2, a 0, a 1, and a 4. Negative 2, 0, 1, and 4. And again, I'm just evenly spacing them. We don't care about the spacing there. Remember that asymptotes always get open circles. So the 0 and the negative 2 are open circles no matter what's going on with that inequality. Then since the inequality is less than or equal to 0, these are both closed circles. So you can have a mixture of them on there. It could even be like every other one. They don't have to be like grouped together. It's just how that worked out on this one. Okay, everybody with me so far? You understand where everything came from and why we did it? All right, so now we start checking numbers. We're going to start with, we'll start with negative 3. So negative 3 in here is going to be negative and then negative. The denominator would give me negative and then negative. So those 4 negatives together give me positive. Then I can use negative 1. So that would give me negative, negative in the numerator, negative, positive in the denominator, which overall means that is negative. Then I can use 1/2. So 1/2 will give me negative, negative in the numerator, positive, positive in the denominator. So overall that is positive. Then I could do 2. So 2 in the numerator will give me positive, negative, then positive, positive. So overall that is negative. Then if I use 5, that's going to give me positive, 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 positive. And this one alternates also. But once again, that does not happen every single time. So just keep that in mind. Okay. We okay so far? All right, good deal. So now we're going to shade. This is positive, this is negative, this is positive, this is negative, this is positive. Okay. And we want this when our function is what? Less than or equal to 0. So we're looking for the negative. So it's just these two down here. So from negative 2 to 0. Do I include the negative 2 in the 0? No. So that's open, open. And then 1 to 4. Do I include the 1 and the 4? Yes. So that's why it's very important that it's done correctly on your number line, because that's much easier to get that information off your number line than it is to go back and re-reason through the function itself. That is your answer. Okay. What questions do you have? Anything? It's totally not a y. It's just the intervals. That's just it. Yeah. You just write it in interval notation. Yes. All right. Let's look at number 8. Okay, so number 8, I need to set it to 0, right? So I'm going to take the stuff that's on the right-hand side and move it to the left-hand side. So this is going to give me 9 over x minus 4 minus 8 over x minus 3 is less than or equal to 0. I need this to be all one term in order for me to use it. So what do I have to do? Common denominators. I got to do my fraction stuff, right? So I have to multiply, so that means my denominator in the end is going to be x minus 4 times x minus 3. And I absolutely do not want to multiply those together because the whole, after I'm done, I want to factor everything out anyway. It's already factored for me. So I have to multiply the 9 times x minus 3 and the negative 8 times x minus 4. So then in the numerator, I do need to distribute it because I don't have it, it's not all multiplication up there. So this is going to give me 9x minus 27 minus 8x plus 32 all over x minus 4 times x minus 3 less than or equal to 0. Then can I clean up the numerator some? Yes, I can. So this is going to give me x plus 5 over x minus 4 times x minus 3. And all that is less than or equal to 0. So this is what I'm using to make my sign chart with. The things I have to find my zeros. What's that? -5, and that's it. I have to find my asymptotes. And yes, x equals 4 and x equals 3. I started writing in parentheses. X equals 4 and x equals, equals 3. So then I have 3 things that go on my number line. 1, 2, 3. So that gives me a -5, a 3, and a 4. Okay, so -5, is it opened or closed? Closed. 3, is it opened or closed? Open. 4? Open. Good. If you have asymptotes, never possible for them to all be closed. It is possible for them all to be open, but it's also possible for them to be mixed. Okay, so then here I'll use like -6. Or actually, you finish the sign chart. You do the sign chart and finish it up. I'll give you a second to do that on your own. Okay. Do you agree with me? Do you have any questions? Well, good? Yep. Alrighty. Then grab your assignment and you can go ahead and get started.